August 11th, a golden day in math history. Seriously, you might just think it's another day on the calendar, but on this exact date, across completely different centuries, absolute geniuses changed the world we live in today. Let's dive right into this explainer and look at the incredible invisible architecture powering our modern lives. 1836, 1889, 1995, and 2003. We're going to travel across this timeline to meet four brilliant thinkers, and I'm going to show you how their purely abstract ideas turned into the very tangible reality you and I experience every single day. But first, let's kick things off with a question. Have you ever actually stopped to wonder how a computer knows how to run your favorite smartphone app? Like, how does a piece of glass and metal literally understand what to do when you tap a digital button? Well, the answer leads us to Alonzo Church, who died on August 11th, 1995. He created this mind-bending concept called Lambda Calculus. Now, back in the 1930s, way before smartphones or the internet were even a glimmer in anyone's eye, Church created this purely theoretical logic. Basically, he figured out a universal way to define and calculate functions. And today, that very framework is literally the foundational logic making all our apps, software, and essentially all of computer science possible. He gave computers a language of logic before modern computers even existed. How wild is that? And here is exactly why his work matters to us right now. Every tap on your screen is just his logic in action. His theoretical math from decades ago is living in our phones right now, guiding the software that powers our daily routines. Okay, we're still on August 11th, but let's jump back on our timeline to the year 1889 for our next mystery. Think about this for a second. Why does your GPS map always find the absolute fastest route, even when there's a crazy maze of hundreds of roads, detours, and heavy traffic? How does it instantly calculate that perfect path? That particular mystery is solved by Andrei Razmadze, born on August 11, 1889. His massive contribution was his pioneering work in something called the calculus of variations. Now, don't let the technical name throw you off. In plain terms, this is the mathematics of finding the absolute best, most optimal path through a chaotic network. Razmadze helped advance the formulas that allow our devices to figure out the absolute shortest, most efficient routes in highly complex systems. Just think about the scale of this for a second. The fastest path was mapped by his math decades before the first GPS was ever a thing. He literally laid the invisible mathematical tracks for our modern navigation systems before cars even had radios. That is just incredible. Moving on, let's jump back to 1836 and see how this very same date builds into an entirely different science. Same date, whole different world of discovery. Let me ask you this. How do we know exactly how to mix chemicals to create those incredibly powerful rechargeable batteries sitting inside your smartphone right now? Like, how does chemistry know exactly how to behave so predictably every single time? This takes us straight to Cato Guldberg, born on August 11, 1836. Guldberg, alongside his collaborator Peter Vogt, created what is known as the law of mass action. Basically, he gave chemistry a mathematical formula. Before this, mixing chemicals involved a whole lot of trial and error, but Guldberg wrote the mathematical rulebook that shows us exactly how substances combine, react, and reach a state of equilibrium. It's a perfect example of abstract math literally and physically powering our world today. He gave chemistry the math it needed to power our modern lives. Every time you charge up a device, you are relying on the strict, predictable chemical rules that he helped mathematically define. One date. So many incredible stories. Let's return to our timeline one last time and jump forward to the year 2003 for our final great mind. Have you ever noticed how incredibly massive 3D video game worlds, with all their textures, complex physics, lighting, and environments, can somehow be structured and compressed to fit right into a pocket console or your phone? How do we mathematically manage such insanely complex digital spaces? The answer to that leads us to Armand Borel, who died on August 11, 2003. Borel worked heavily in these fascinating areas of math known as algebraic topology and Lie groups. To keep it super simple, his work is all about understanding the hidden symmetries of extremely complex structures. By finding these perfect symmetries in giant, chaotic shapes, we can actually map them, understand them, and ultimately compress them into manageable pieces of data. And this right here really illustrates his ultimate genius. He found the hidden shapes inside the chaos. Where others just saw a messy, impossible structure, Borel's math found the beautiful underlying order. So let's bring all 4 of these incredible years back together on our timeline. 1836, 1889, 1995, 2003. Every person we explored in this explainer, living in completely different eras, different countries, working on totally different problems, they were actually united by a single powerful mission. They all asked the exact same question. What is the pattern hiding inside the chaos? And because they asked that question, our world today has GPS mapping, pocket-sized video games, powerful chemical batteries, and the modern internet. So I want to leave you with this provocative thought as you look at your phone, your apps, or your maps today. What pattern is hiding inside the chaos around you? And what invisible math is secretly powering your world? Keep asking questions, keep looking for those patterns, and I'll see you in the next explainer.